Math 98. I am going to go over lesson 3.6 today. It's called Balancing Blood Alcohol. So this week, just so you have an idea, today we did 3.6, Wednesday we're doing 3.7, and that's the last lesson we're going to do in Module 3. So I already uploaded a Module 3 review sheet. You can kind of take your time and work on that throughout the week. And then in the class, whichever class you're in Thursday or Friday, you can just bring any questions that you have about that review sheet, okay? So then your test will be next week, most likely Monday of next week, but I will give you a definite date and time on that in a day or so, okay? And it'll be set up the same way as before on the Carnegie website, open for many hours like it was last time, and then you can just, once you open it, you have 2 hours to finish it. Alright, so if we look at lesson 3.6, there's really not a lot of new material in 3.6, okay? We're really using what we kind of started doing, especially with 3.4, which was the braking distance one, talking about formulas and equations and kind of substituting in for various variables as we need and holding some variables steady. So you see in this problem situation, it says blood alcohol content is a measurement of how much alcohol is in someone's blood. It is usually measured as a percentage. Now the tricky thing is, it's not usually written with a percentage sign. Okay. So here it says 0.3%. Usually we would just say, well, that person has a blood alcohol of 0.3. We know, being mathematicians, that 0.3 is the same as 30%, okay? But that is not what this really means. You would not want 30% of your blood to be alcohol, right? So really, it's 0.3%. It's already a percent, but the percent sign isn't written, so it's just a little confusing like that. So if a blood alcohol is 0.3, well, think about it this way. If we had a blood alcohol content of 1, okay, that would be like 1%. That would be like saying there's 1 gram of alcohol to every 100 grams of blood, right? 1% is 1 out of 100. This is less than that. This is 0.3%. So this is saying there are 3 grams of alcohol, not for every 100 grams of blood, but we have to go 1 extra place value over for every 1,000 grams of blood. Okay. It talks a little bit about the impairments at different blood alcohol levels. In most states, the legal limit for driving is blood alcohol. Again, we hear it as 0.08. It's really 0.08%. Okay. So think about 1% would be 1 out of 100. This would be out of 1,000. This is out of 10,000. So 8 grams of alcohol for every 10,000 grams of blood. You don't need to be able to calculate this. I just kind of wanted to mention that so that when you see these in the news or whatever, you understand what that means. So if we look at the next page, there is a formula there. And it says BAC is usually determined by a breathalyzer, urinalysis, or a blood test. However, the Swedish physician E.M.P. Widmark developed the following equation for estimating an individual's BAC. This formula is widely used by forensic scientists. So it's an estimate. It doesn't take into account everything, but this is a little bit simple version, but it gives us the right idea. So B equals negative 0.015 T. Now there's a dot here for multiplication in there. We don't have to write it. Plus 2.84 N over W times R. Okay, so first of all, you do not ever have to memorize this. We will use this. You could be given a problem with this in your test, but I will always give you the formula. Okay, if you're using it in homework, it will either give it to you in the problem or you can look right back in your lesson. Also, then you see right below that where it has all of those variables defined. So capital B is your BAC. If we go in order across here, T, that's at the bottom of the list, is the number of hours since the first drink. So T is time in hours. Over here, capital N is how many drinks the person has had. Capital W is their weight in pounds. And R is a distribution rate for alcohol throughout the body. That value is a constant, but it's a different constant for males than for females. So that's why it's still a variable there. This 2.84 is just a factor that has been figured out scientifically that deals with the alcohol as compared to the water in the blood and how it metabolizes and that kind of thing. So let's just take a look at this for a minute. We notice that there are two terms, okay? If I look at this term, it's a negative number times t. So think for a minute about why that makes sense to have a negative number here times t. Think about what t equals and what you're trying to find. Okay, so t is the time, right? So if you think about if you have a drink, and then let's say you don't drink anymore, and as time goes by, your blood alcohol level is going to come down. So that's why this is negative. The bigger that time gets, the more I'm subtracting from my blood alcohol. It's going down as time goes on. This part over here, now this is being added. This is going to be positive. All these things have to be positive. The number of drinks, your weight, and this distribution factor. So this is going to be positive. So this part is going up as it's going to send your blood alcohol content up, right? Now when we have a fraction, if the numerator gets bigger, then the fraction gets bigger. If the denominator gets bigger, then the fraction gets smaller. So for example, if the denominator gets bigger, if I have 1/2, if I make the denominator bigger, this is a smaller piece of my cookie than this is. So if the numerator is bigger though, then that makes this bigger. Well, n being the number of drinks, the bigger that gets, the higher your blood alcohol content. Look at the denominator. The bigger your weight is, the less each drink is going to affect you. And the larger that metabolism factor or distribution rate, the less it's going to affect you. So if you look at that where it lists the variables, the distribution rate is larger for males than for females. So a male with the same weight, same number of drinks, etc., is going to have a lower blood alcohol slightly. Okay, I'm assuming that probably has to do with just hormones in the body and the way they metabolize things differently. Okay, so that was number one, really, right? Thinking about why the items on the right make sense in calculating your blood alcohol content. So let's look at number two. We have a male student who weighs 120 pounds and has 3 beers. Okay, now notice when we talked about the number of drinks up here, it's a number of standard drinks. So it's a 12-ounce beer, a 5-ounce glass of wine, or a 1.5-ounce shot of liquor. Okay, someone can't have 10 ounces of wine and say, oh, I only had 1 drink. So it has to go by whatever that standard size is. Okay, so this male had 3 beers, weighs 120 pounds. Simplify the equation as much as possible for this case. So similar to when we looked at the braking distance problem, and we plugged in for little g, which was the acceleration of gravity, f, which was the friction coefficient, and capital G, which was the grade of the road, and we figured out that as much as we could, right? Then we only had a couple of variables. We're going to do the same idea here. So what I'd like you to do, this is number 2 on that page, what I'd like you to do is go ahead and substitute in for what you know. There should be 3 things you're substituting in for, and then simplify that as much as you can. Okay? Go ahead and pause the video, and then when you're done, go ahead and check your answer up here. So I'm going to do it up here. You go ahead and pause the video and then try it on your own. Even if you don't get it, that's okay. Okay, you know from our class that you have to try it and make mistakes in order to learn it. So go ahead and try it and then start the video up again when you have it. Okay, so we don't know anything about blood alcohol content. We don't know anything about the time. What we do know is that this person had 3 beers, right? 2.84 times 3, that's what their multiplication shows. The weight is 120 pounds, and for a male, the distribution rate through the body is 0.68. Okay, now if you notice, everything over here is a number. Okay, so we can just go ahead and simplify that. Now let me just caution you about something. What you cannot do is put this in your calculator like this. Okay, this would be dividing, because depending on your calculator, it's going to say, okay, I'm going to do this, and then I'm going to divide, and then I'm going to do this. Okay, or it's going to divide these two. It's, so it's going to kind of mess up the order of operations. Okay, what you want to do is you want to have it multiply these, and then divide. So if you're putting it in your calculator all at once, you must have parentheses around it. If it's the kind of calculator where you can see the display, you can put everything in. Okay, then you want to multiply these, divide. Or you can just put it in one at a time. Multiply these two, get a number. Multiply these two, get a number. Then divide what you have. And we'll go ahead and round it to 3 decimal places. So we should then have b equals negative 0.015t plus 1.104. Okay, so this has all this information for this student plugged in, except how long it's been since he drank those 3 beers, and what his blood alcohol content is then in that case. But number 3 says, using the simplified equation, which is this guy right here, find the estimated blood alcohol content for this student 1 hour, 3 hours, and 5 hours after his last drink. So think about where that's going to go. There are 3 different parts there. You're going to have 3 different answers. So at first we're going to have, what's his blood alcohol content 1 hour after his last drink? Where does that 1 go? Well, it's going in time, right? Time and hours. So we're going to have b equals negative 0.015 times 1 plus 0.104. And we're going to find our answer. Okay. And then it also asks for, so it asks for what's his blood alcohol content after 1 hour, after 3 hours, and after 5 hours. I've set it up for you for 1, so go ahead and figure out what the blood alcohol content is after 1 hour, and then do the work out also to figure out what it is after 3 hours and what it is after 5 hours. Okay, I'm going to stop this video here. I'll start it up again with going over these answers, but please take the time to do them on your own before you come back.